Our third and final video of the inverse equation lesson. And this is the part where we start applying inverses. So it says here, functions that model real-world behavior are often expressed as formulas with meaningful variables. So such as like the area of a circle, any physics type formulas, chemical type formulas. We have specific meaningful variables in those types of equations. So it says here, strictly speaking, the inverse of the formula for area of a circle would be r equals pi times the area squared. But when we do this, when we switch essentially the independent and dependent variable, this expression presents a false relationship between the area and the radius, okay? It is better to leave the variables in place and solve for the variable that you are looking for, okay? So when it comes to real-world type formulas, you don't want to switch the variables. You just want to solve for that other non-isolated variable. So as you see here, a equals pi r squared. If you want to solve for the radius, just do your algebra skills to solve for that radius. So we're going to look at an example here, problem number 5. It says the function d equals 4.9 t squared represents the distance d in meters that an object falls in t seconds due to Earth's gravity. You want to find the inverse of the function, and they also want you to figure out how long in seconds does it take for the cliff diver shown to the right to reach the water below. So as you can see here, you don't want to mess with that equation because that represents gravity. That is a meaningful and powerful equation, so we don't want to go switching variables here. We just want to solve for the other specific variable. We want to solve for t here because it's asking us how long. So as you can see here, all we have to do is get the t variable by itself. You're going to first divide by 4.9, and then you're going to take the square root. The reason you don't have to have plus or minus here is because time will not be negative. Okay? You would only want to consider the positive solution here. And where did they get that 24 from? The cliff diver was jumping 24 meters, so that's what you plug in for d and you solve. So let's try it ourselves. The function d equals v squared over 19.6 relates the distance in meters that an object has fallen to its velocity in meters per second. This is another very crucial formula that we use, scientists use, so we don't want to go messing with it. If we want to find the inverse, we just want to solve for v. So we're going to have d is equal to v squared over 19.6. I'm going to multiply out the 19.6 on both sides, and I get 19.6d is equal to v squared. So now to solve for v, I'm going to take the square root. So I get v is equal to the square root of 19.6d. So this is my inverse equation. So now I'm ready to answer the question, what's the velocity of the cliff diver in meters per second as he enters the water? So we can go back to the last slide and see that d was still, what was it, 24? Yep. So I'm going to plug in 24 for d, and I will get my answer. You obviously want to do this on the calculator. But when you plug this in, you should get about 21.7 meters per second. And that's it. That's all there is to it. The last thing in the inverse section I want to talk to you all about is being one-to-one functions. Okay? And the only thing you really need to know here is this bottom part. So yesterday, if you remember, we talked about function composition, that open circle where you put a function inside another function. So if you have the function composition of the inverse with respect to its original equation, and you have a value of x, your answer is just x. And that will go both ways. you're going to take the inverse of the original function or the original function and then composite the inverse, you're still going to get that specific value. So for example, if you were taking the f inverse of f with respect to 2, your answer would just be 2. And that's all. If they are truly one-to-one functions, this will work. Now, for my first and fifth block, if you're really interested in seeing how this works, I will be more than happy to show you all that if you want to come in before or after school. But like I said, the biggest thing that you need to know here is just knowing that you get out the value that you put in. And that's all we have for inverse functions. If you have any other questions, feel free to come in and ask me. I'll be here this afternoon. Or you can come in and see me Thursday anytime. I hope you all have a great day.